Somebody tell me the square root of 16. 4. What about the square root of 64? 8. What about the square root of 100?
10.
Excellent. What about the square root of 36? 6. What about the square root of 81? 9. What about the square root of 625?
I don't know either.
25. What about the square root of 25?
5.
What about the square root of negative 25?
Negative 5. No, they can't. It can't. It's impossible.
What have we written?
Impossible.
No, we did not write impossible.
No real numbers.
No real solution. And until today, that was your answer. No real solution.
This is going to be fun.
Okay? You know, because of properties of square roots, that you can divide this into 2 parts, right? You know, because of properties of square roots, you can divide it into these 2 parts. Do you know the square root of 25? 5. And now you know the square root of negative 1. The square root of negative 1 is I. The square root of negative 1 is I.
Wait, do we have to write our I like that?
Yes, do not write it like that, because you'll forget the dot and it will look like a 1. Put a little tail on your I. Okay? I would tell you to write it in italics, but you don't write in italics. Okay? If you type it, it's in italics. Okay? Now, am I going to get mad at you if you just write it like this? Probably, because you're going to mess up because you're writing I like this. Am I going to count it wrong? I can't count it wrong. I just want you to write it like this so we don't have errors because of that. Fair? Okay. Okay, so what does that mean? It is imaginary. The I is for imaginary numbers. Okay? Today we start talking about complex numbers. You knew that because you already wrote it down in your lesson plans. Okay? But anytime somebody sees the word complex, they automatically assume it is hard. Okay? Can I prove to you that that is wrong? Okay, let's talk about a couple things. First of all, a complex number looks like this. This right here is the real part. This right here is the imaginary part. And you can tell it's the imaginary part because it has the I. There's some things you can do with complex numbers, and there's some things you can't do with complex numbers. Okay? First of all, let me show you some things that you can do. 2 plus 3i plus 5 plus 6i. Can we add complex numbers? Yes. What parts of complex numbers can we add? So we should add the real parts, right? If I add the real part, I get 2 plus 5. Guys, what is 2 plus 5? Okay. Scared me for a second. Can I add the imaginary parts? 3i and 6i. 9i. Can I add the real part and the imaginary part? The only place that works is Space Jam. The only place it works. Also works in Who Framed Roger Rabbit, but not everybody knows that movie.
Wait, Who Framed Roger Rabbit?
Okay. Some people know it. Most people know Space Jam, that's why I went with Space Jam. Okay? Can you subtract them?
Yes. No. Well, yes.
3 plus 4i minus 2 plus 6i. What parts can we subtract? The real parts. 3 minus 2. 1. Where are you going to mess up right here?
The
Imaginary parts. Why are you going to mess up the imaginary parts? Because you're going to forget we are subtracting. Are you allowed to say this is really adding a -2 and a -6i? Didn't I just distribute a negative sign or a -1 into each term?
Yeah.
And isn't that allowed? Yes. Is it required? No. But for visual people, this is a lot easier to see, 4i and -6i. Right? Five plus 2i minus 7 minus 3i. Real parts? -2. Imaginary parts. 5i. Why is it 5i?
Because you're subtracting a negative.
2i minus a -3i. Again, you got to be careful. Okay? You know ways to get around that. Distribute your negative inside. You can see both of these have a different sign. Or just remember that you're subtracting. Is one righter than the other? I know that's not a word. I just said it anyways. It's fine. Is one more correct than the other? No. Okay? 4 plus 6i, 3 minus 2i. Can I add real parts? Can I subtract real parts? Yes. Can I multiply real parts?
Yes.
Yes. Can I add imaginary parts?
Yes.
Can I subtract imaginary parts?
Yes.
Can I multiply imaginary parts? Yes. Can I add real and imaginary? No. Can I subtract real and imaginary? No. Can I multiply real and imaginary? Could I multiply 2 times 4?
Yeah.
Could I multiply 2 times 4x?
Yep.
Yeah. Is I a variable?
Yep.
No, it's not. It represents an imaginary part of a complex number, right? But sometimes we treat it like a variable. This is one of those cases where we can treat it like a variable. I can multiply real and imaginary parts. Yeah, don't whoa me as if I was a horse. Okay? 4 times 3, 12. 4 times -2i, -8i. 6i times 3, 18i. 6i times -2i, -12i squared. What do you think we should do? I should combine my imaginary parts, right? These two. Can I combine it with this one? No, I can't, but I can sure combine these two, right? 12 plus 10i minus 12i squared. Let me let you in on a secret. Well, it's actually not a secret. You just don't know it yet. Okay? We're going to take a commercial break real quick. And we're going to remember what I said about -1 being equal, or square root of -1 being equal to I, right? What if I squared both sides? Wouldn't that tell me what I squared is equal? It does. I squared does equal -1. Because if I equals the square root of -1, if I square both sides, that gives me I squared. And if I square something that's being square rooted, don't I just get what was inside? So here, this right here equals what? -1. What's -1 times -12? What is 12 plus 12? 24 plus 10i. That's my answer. I said, that's my answer. Let me show you something else real quick. Actually, not real quick, because it's going to take me just a minute to get it ready for you. I want to make a new document. Know what? I want to save my old one for a calculator, right? If I take the square root of negative 16, what should I get? What did I get? No real solution, right? Can a calculator do this? Yes, but you have to fix it. You have negative 3 seconds to grab your calculator if you haven't grabbed it already. Go to the home button. Go to the settings. Everybody go to the settings. Do you see the document settings? Number 2. Look right here. Real or complex. Well, here's what's funny about that. When you choose it, it doesn't give you real or complex. It gives you real, rectangular, or polar. Okay? We're going to choose rectangular. Why? Because that's what I said. Sometimes you need to know, sometimes you just need to accept it, and we go on. Okay? After you choose rectangular, get your cursor to go down to Make Default. When you hit Enter on Make Default, it's going to say, do you really want to do this? And you're going to say, okay. Because now when I go to a new document, and I make it a calculator, and I say the square root of negative 16, it tells me my nickname when I was a little kid. Yeah. Brings back such good memories. Okay? But here's this. I want to blow your mind. 4 plus 6. Look at the pi button right here. That's the I you want to use. Don't try to use the alphabet I. It will not work. Times 3 minus 2 I. Huh. Oh look, that's what I got. Why didn't I show you this first? Because you got to know how to do the math, right? Are you going to have one of these calculators at your house tonight? No. So are you going to be able to do this by yourself?
No.
Yes, because you already know how to do this. I showed you how to do it, right? Every single step. If you're at school, do I want to see every single step? Yes. We're using our calculator too? Check. The math is what's more important, not knowing how to use the calculator. You guys know that's how I feel, right?
Yeah.
Okay. Now, there's something I want to show you, and I'm just showing it to you for now. We will get into it in the next couple days, but I at least want to introduce the concept to you today so that when we get there in the next couple days, it's just like oh yeah, I remember that, and we can go on. Okay? We'll actually talk about it at the end of this lesson and then again in the next couple days. You okay with that? Complex conjugate. C-O-N-J-U-G-A-T-E. They couldn't read my writing earlier. Sorry it's so messy. I think it's my cursive that they can't read.
Really? It's too pretty, it's blinding them.
Is that better? You guys are so weird. Here is my complex number. 4 plus 6i. Okay? I want you to tell me the complex conjugate. The complex conjugate is 4 minus 6i. If I tell you the number is negative 3 plus 2i, what is my complex conjugate? Negative 3 minus 2i.
Oh, so it only changes the sign. It's not like if it's negative or not?
It only changes the imaginary.
It only changes the imaginary part. What if I tell you that my actual number is 5i? What's my complex conjugate? Negative 5i. What if I tell you that my number is 6? What's its complex conjugate? 6. I mean, we need to have an argument whether that's a complex number or not, but that's not for now. Okay. What would it really need to look like to really be a complex number? 6 plus, so like 0i.
Yeah.
Okay. But you can't really have minus 0 as opposed to plus 0, so it's still just 6. Does that make sense? Okay. We're going to use, like I said, we're going to use these in the next couple days. I'll talk about it at the end of the lesson real quick. But I just mostly wanted you to have that in your arsenal. You ready? Ready for the next step? Okay. So the next step is like this. I'm going to say to you, here's an equation. X squared plus 25 equals 0. How do I solve that equation? Now we need to isolate the x squared, right? And then from the x squared we can isolate the x. If I subtract 25 from both sides, I get x squared equals negative 25. So when I try to solve for x, how do I do that? Square root. Both sides, right? Square root here, square root here. Who put the square root sign into the problem? We did. Then what do we also have to remember? Very good. Plus or minus? Plus or minus what? I heard the answer a minute ago. 5i. Huh. That looks like to me a number and its complex conjugate. Doesn't it? Guys, how many answers am I supposed to have? 2? If all I wrote was 5i, would I have 2 answers? No. The answers that I should get are the number and its conjugate. Or the number and its conjugate. Does that make sense? Okay. So if I told you one of the answers, couldn't you figure out the other answer? If I told you, here's along this imaginary, well, I can't say imaginary anymore because that's a real thing for us now. Not a real thing, but imaginary thing. What if I said one of my solutions to all this work that's on another page was 2 plus 6i? You know I'm supposed to have 2 solutions. What's the other one?
2 minus 6.
Mm-hmm. That's where complex conjugates come into play. Okay? What about this one? 5x squared plus 35 equals 0. Minus 35, you're correct. Which leaves me with 5x squared equals negative 35. Divide both sides by 5. Equals negative 7. And then square root of both sides. Here's my favorite part. And yours. It's the square root of negative 1. I. What's the square root of 7? I don't know either. What am I missing? Plus or minus. The number and its conjugate. Questions? One more. You ready for one more?
Yes, ma'am.
Yes. I love when you're ready for one more. 2x plus 3 squared equals, I don't know, what do you want it to equal? No, 0 is not good. Negative 10?
Yeah.
Okay.
Distribute it.
Oh, I don't want to do that though.
Divide by 2.
Divide by 2. X plus 3 squared equals negative 5. Can't I take the square root right now?
Yes.
I isolated the thing being squared, right? So I can solve that by taking the square root. x plus 3 equals what? Plus or minus I square root of 5. Do you know the square root of 5? No. I don't either. Okay? But I know the square root of negative 1. That's why I pulled that out in front. Guys, why am I not writing it at the back? Don't we normally write our variables at the back? I know I is not a variable, but don't we normally write it at the back? Okay, go ahead and tell me right now if that I is inside or outside.
I don't know.
I don't either. Okay, that's why we write it in front of the root sign, because it's too difficult to tell whether it's in or out. Now I know for sure that it's out. Okay?
Minus.
So that's my answer?
No, you have to get the.
I still have to get the x by itself, right? If I subtract 3 from both sides, huh? Do I take the 3 away from the 5? Well, I can't do that, can I? Because this is real and this is an imaginary.
Negative 3 plus minus.
Negative 3 plus or minus I root 5. Real part. Why does the real part come first and then the imaginary part come second? Because traditionally that's how mathematicians write it. And since we are mathematicians, that's how we will traditionally write it.
So what if you put that at the back? Would it be wrong?
If you put plus or minus I root 5 minus 3, you can get into the whole thing like we had up here, where if you accidentally draw that too long, I don't know if that's inside or outside, and then somebody might try to actually subtract that and make it 2, and ugh. It's just better if we write the real part first and the imaginary part second. Okay? Like I showed you at the beginning, in our complex numbers, we traditionally write the real part and then the imaginary part. Even the letters that they chose are even alphabetical, so you write the A part first and the B part second. Okay? Is it wrong the other way? No, it's just not in the traditional form. And a lot of times the traditional forms can be silly, but in this kind of case, it keeps us from messing up with our math right here. So we don't want that. We want this. Am I going to count this wrong?
No.
Probably not. But I would rather have it this way. Does that help?
Yes.
Any questions?
I do.
Ask.
On the example we did before this last one.
This one?
Yes.
Okay.
Wait. Oh, I didn't finish it, but I didn't have plus or minus.
Oh, okay.
But, yeah, you can.
So
Any more questions?
On
Yes.
the last one?
This one?
No.
This one.
Yeah.
Okay.
So if you wrote it in complex, it would just be x equals negative 3 plus I root 5, and then the other would just be negative 3 minus.
So if you want both answers separately, it would be negative 3 plus I root 5 and negative 3 minus I root 5. Yeah, that's a good question. Okay, those are your two answers that we knew we needed to get. Okay? Any other questions?